Let's go. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go. Let's go. Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go. Let's go. Let's go. Let's go.
Let's go. Good morning, good afternoon, good evening, good whatever, wherever you find yourself. Welcome to IoT Tuesday, the only IoT show that live streams easy and simple ways to learn IoT, demystify and make it easy for the average person willing to get into the world of IoT. I am yours truly, Samuel Adrani, bringing you another episode 74 to be precise. Yeah, 74. And sorry for the late transmission. As you know it, some of these things are technical. My show is a live stream, so when I'm about to go live and things happen, I have to, fix them and try to go live. So thankfully that's fixed and we're going to go live. So in today's episode, we're going to do part 2 and probably the last part of the Seed Studio XIAO family of, like microcontroller boards, tiny boards that allow you to do big and crazy things. From there, we'll probably be, we'll segue into building actual solutions with all the numerous XIAO boards that I have unwrapped, unboxed, unveiled, and, shown how to use on the channel. If you missed it and it's your first time, please do well to help us subscribe to the channel, hit the notification bell, so that when I release any new video or when I go live, you would get the notification. As always, before we get into the action, let's go for the intro. We'll be right back. Yes, if you want to learn IoT, this is the only show that demystifies it for you. Welcome. Send me just say a hi or thumbs up or something anywhere you're watching me from now, specifically just either on LinkedIn or YouTube, which have become the two main channels I stream now since Restream changed their licensing package. I'm still waiting for Restream to say, hey, you know what? You've been streaming all the time, so we're giving you, a free 1 year upgraded plan. Maybe I'll take it. Any which way, still we get there. So in today's episode, we'll be going part 2 of communication with the XIAO ESP32C3 specifically. We'll be leveraging on Bluetooth. We talked about Bluetooth last week. We tried to use the app. I found some cool things on the app because it has been updated to the app. So I found some cool things to the app. And what we'll do is that we'll go back to see how that communicates with it. And then we'll put everything together from when we started using the XIAO. That would be trying to control, trying to send or control devices connected to the XIAO from an app which is connected to it or communicating to the XIAO via Bluetooth. That's just to give you some idea on how to put all those things together. And then next week, we're going to completely begin a new series of building something, and I would unearth that or unveil that next week on the show. So do sure to come join us next week. So my monitoring cable is all over, so you guys can see that I'm monitoring something. Shoot, you caught me. Anyway, which is something that you can see all the time. So before we get into it, as you always know, I like to put a couple of things out there for you to know what's happening in the world of IoT. So let's go and check this out. So first off is a workshop. Okay, let me actually bring my zooming stuff here. All right, awesome. So it's a hands-on workshop on using training and deploying your own AI model into a vision AI sensor. All right, and this is something that C Studio is hosting, providing you this. They have all this kits specifically to vision that you can use. This is happening on September 29th. All right, September 29th. Where is that? I think I can drop. You know what? I'll drop the link. It will be part of the show description if you watch it after on YouTube, but I'll drop it in in the comment section as well. So 12 to 1 p.m. Pacific Standard Time, 29th is going to be, it's a virtual stream, so you don't have to be there. You can just join. So I think the event is on LinkedIn. So I'll drop the link. Go check it out. And then, hey, just learn something interesting. I am attending, as you can see, so I'm sharing this for you. So that's the first announcement. Now, the second cool thing, the second awesome thing I want to talk about is if you are not aware, Microsoft has pretty much a best practices or architectural guideline or samples section on the Azure website. All right, and then there is something called well architected framework. Okay, they call it the well architected framework, and it's pretty much documentations and resources provided by Microsoft and its experts, engineers and people in the industry that have put together practical or industry standard ways of architecting different kinds of solutions on Azure. So it could be, IoT, containerization, app security. They put together some architectural designs and patterns for you to use when you're dealing with Azure. And they have released one for industrial IoT. So giving you access to ways to properly architect your industrial IoT project or solutions when leveraging. Most of it, even though speaks to a lot of the Microsoft IoT offerings, all right, Azure IoT offerings, some of the ideas and concepts can, are platform, independent. So you can pretty much leverage some of the skills or some of, the lessons learned across your cloud. But then this is specifically to Microsoft. So yeah, so pretty much gives you access to that, different features of your project, and handles a lot more things. So that's the second thing I'm going to get out of the way. Now, before we get into today's session, all right, we've seen a lot of things about the XIAO. Now, a couple of things I want to share about it for you to know before we get into today's session is that is the pin multiplexing on the XIAO. All right, it's a very small board and has a lot of pins on it. Now, most of the pins, okay, or the interface or IOs can actually be multiplexed in the sense that they can be used for different, they can interface differently. So one pin or one IO pin can be used for digital as a pulse width modulator, as an analog input output, as a serial input output, as an I2C input output for hardware connection. Both there's a way to do that in the hardware and a way to do it in the software setup. And then also SPI, all right? So don't think that because it's a tiny board, there isn't ways to, multiplex the pin. You can't do that. So for example, if you look at this setup here, say if you connect a push button to digital pin, 6, right? And then you put an LED on pin 10, you can upload this code and control the on and off with this simple logic here. So you realize that now pin 6 and pin 10, all right, are being used as digital input output, all right. So let me share something with you real quick. Where is that? Let's get this. So let's see this. Let's do and so you realize that was one of the reasons. Okay, that was one of the reasons as when we're trying to connect our temperature and humidity sensor, it wasn't functioning the same, because then we had to indicate or tell it that, hey, we're using the digital pin because the pins can multiplex. All right, so pretty much, yeah, that will be it. And let's see. let's do this. Maybe we'll try this and leverage this. Okay, so we'll come back to this code. Now, aside that, we can also leverage it as a digital pulse width modulator. All right. So, and this, you can still connect LED to pin 10, and then you can do gradual fading using a potentiometer. All right. So in this case, they are fading it here, and you can see it's still digital pin 10, but using not not an analog PWM, but a digital PWM. So you can do that as well. Okay, then as an analog input output, again, as you can see, and I'm sharing this to realize that now if you connect a potentiometer, all right, to pin A0, all right, saying that pin 0, but we're using that as an analog prefix with A, and then LED digital pin 10, you can upload this code and then use the potentiometer, to increase or decrease the brightness of of the LED. All right, so that's and then serial as well. You can also use it. You can use it as a serial interface, okay, on the board. Now, so by default, the USB serial is enabled. Okay, so which means you can just connect it to a PC with USB Type-C, and that serial communication can go. You can communicate with it via serial port. Okay, now if you want to do UART or do some other serial things, you have to connect it to the transition pins, right? So digital pin 7, so realize that this case, if you look closely, if you look at this, let me make this a lot bigger. So realize that in this case, you see the receive and transmit pins, but you realize that the same pin, digital pin 6, can act as a transmission, and the same pin D7, okay, can also act as the receive. All right, so multiplexing, you can use that. Okay, awesome. So yeah, that's not all. And then I2C as well, you can also leverage it on as I2C. Let's go here. Let's do this. So in this case, you can see that up here, volt ground connected to this, and then the SDA and SCA. Now, which would be, if we just quickly go back, SDA here would map to you see digital pins. Look here, so digital pins 4 and 5 will still be multiplexed to use SDA. All right, and then you can change that in code. Now, using I2C, you can set it up the hardware way, or you can also set it up the software way, but you need a library, U8G2 library, and I'll leave a link to this. I'll leave a link to this resource, okay, for you to go check that out. Okay, considering that that's not the focus of today's session. So awesome. Yeah. So that is generally a couple of things I want to get out, concerning what we've done so far with ESP32 XIAO. So in today's session, last week we saw ways to talk to the setup. Okay. Let's see. Pardon me. Let me bring this here and let's go to the bench. I'll have to set it up a bit. So let's do this. And just give me a sec. Let me set this up. Okay. Okay. So this is what we have so far. We have the temperature and humidity sensor connected to it, and that's the XIAO board right there. Okay. So what I want to do today is to show. Now, in last week's episode, we were able to connect this. Okay. Oh yeah, I think something. Okay, so anyway, no problem. I think there was an update that changed, but that's fine. So I want to connect. I'll connect my phone to an app, a Bluetooth app, okay, that allows you know that allows you to communicate via other Bluetooth device. So right now we've enabled the Bluetooth. We're using the Bluetooth on this. So what we did last week was to be able to send something to the board for it to actually receive that Bluetooth information. All right, it will receive that Bluetooth information. So I'll go over it again, and leveraging on that, first what we'll do is that we'll try to now use the same app. Now this is a pre-built app, okay, but the mechanics works the same. We're now trying to use the app to send a command to the XIAO for the XIAO to turn on or off this LED. Maybe we should use red. So I have this groove LED here, okay, and then we'll try to use the app from the mobile phone to send a command via Bluetooth to the XIAO, and the XIAO can now control the LED on and off. Just to give you an example of how you would leverage, Bluetooth communication in controlling or commanding things on the XIAO board. Okay, so let's go ahead and open our Arduino IDE, and we'll show you the code. Let me also get reflector running, since we'll be using that to show what's happening on my phone. So reflector is showing here. So let me go ahead and connect the phone. Before then, let have our Arduino load. Okay, so we can see reading. Okay, so yeah, so we need this will able to tell us. So let's open recent. I think Bluetooth server. Yeah, so this is what we want. Okay, so this is what we did the last time. Okay, if you missed it, it's nothing crazy. Just go check it out. We just set up a service UID. Pretty much all we're doing was that once we set up, we are sending some value, to how do you call it? We're broadcasting some values out, and then we have this handler here. We have a callback handler that actually outputs everything or anything that is sent to the XIAO via the Bluetooth application. All right. So what I want to do now is I'll try to do a split. I don't know how this is gonna work. Okay, for now, let's just do this for now. Okay. I'll just do this and I'll bring. So this is currently running on. It's currently running on the XIAO. Okay. So let me bring up our. Let's connect my phone, and then we would. Okay, so what is it? Okay, so we have a number I need to use to connect to the phone. Okay, so the phone is now connected. Light blue. So the name of the application is Light Blue. All right. So as you can see, this here is our IoT Tuesday. So this is the XIAO, right? So I'll select this, and now it's connecting to the XIAO. All right. Now, I'll go ahead and let's open the serial monitor here. All right. And let me get the phone. So now it's connected. So let's open this up, and actually let me push this thing here. Okay, we're not doing any cloud connection, but if you watch closely, actually let's go back. Let's go back and let me show you something. Okay, so one thing I noticed, or I realized from the app the last time, was that you realize that now it was running in hex. Okay, it was running in hex, but we don't want it to be running in hex. Actually, you know what? Let me bring the phone here instead and bring the serial monitor here so you can see what's happening. Now, if you look at the top here, you see hex. So if you press there, it changes to ask you how you want to communicate with the application. Okay, let me take you there currently. Okay, so you can see that there is hex, which is being selected. There is binary, oct, and you can do string. All right, string or UTF-8. So select that, and what that does is now it's telling the app that you want to communicate with it using UTF strings, and then you realize that almost immediately it shows you that, hey, I'm connected. And when it connected, look here. So I'm going to bring you close to this side. Now, when it connected, it said IoT Tuesday connected. That was because that was the message. Look at it. This is the message. Let's take this here a bit. So IoT Tuesday connected. This was the message here. We said, hey, anytime you connect, just say IoT Tuesday connected. All right. So now to test whether we are receiving information from our phone in the serial monitor, I'm now going to write. So if you look here, there's read write. So I'm going to do write value. Okay, and you can see UTF is asking me what I want to write. So I can, for the sakes of how do you call it, the test, I will do on, and then I'll be done. And then check this out. Look here. Do you see? It received a new value of what? On. Okay. In the same way, if I go back then, I say, hey, write a new value, and I want to write off. Do you see what's happening? So it's sent off. So we did this last week. If you were not following, you can go back to watch the previous show. So now we've been able to establish communication via Bluetooth between this app and our XIAO, which is acting as a server, okay, receiving this command. So the next thing we want to do, just to show how all the things we've been learning and reviewing about the XIAO is going to play. So what we want to do is that, first of all, if I like, we can decide to even bring in how do you call it, the temperature humidity values, and send it to the app. So because ideally, most of the times you want to build some kind of dashboard or UI that connects with it, that you can use to communicate with it. You want to do that. Okay, that's one way. Then the other part would be, once you're seeing those values, you want a way from your app to connect or control the LEDs or stuff happening locally. So that's what we want to do. So it's just a matter of going back to bringing all the other pieces, okay, leverage them, and then see how it comes in. Okay, so I will leave I'll just leave this for now, and then let's go back and start bringing it in. Okay, so let's even assume that in this case, so what we are doing here is, there you go. So we are saying that we are adding, what was that? Yeah, so we set the callback. So anytime we receive anything, let's use the callback. Okay, so now what we want to do with the callback, and I'll look at this. So it says that if you set this up, okay, I think, hold on, let me see. Where did we set this up? Where did we set this? Okay, so it is here, which I'm sure. So what we can do is, at some point, I was thinking maybe we could just declare this value, okay, and bring it here so that it will be available for us to use within our loop, okay, and then we can use that to set values, okay, as and when we want that. But again, we're testing all these things. All right, so first off, baby steps, what we want to do is that anytime we receive values, we want to, so this is the handler, instead of just writing it, so you see here, it does a new value, okay, and then prints it. Instead of the new value or prints it, what we want to do is that we would want to turn on or off. Okay, we want to turn on or off LED. Okay, so first of all, let's see how we can quickly get the LED to run. Okay, and once we get to that side, we will now go ahead and bring this in. Yeah, I think we have enough time to do this. So let me switch to the bench, and so as you can see, this here is an LED, a groove LED. All right, as you can see. So VCC in signal. Now, one thing you can do is that one thing I like to do a lot when I'm working with the seed stuff is if you have any, if you have any worries or trying to understand, hey, how do I wire that? Very simple. So go to the Seed Studio wiki page. Okay, let me actually copy this. We'll make this also a resource here. Okay, go to it, and so this here, if I turn it for you to see, if we go to the bench, it says here LED socket kit. Okay, so it's part of the groove. So if I go, so now if I go to Seed Studio and I say LED socket kit, you see groove LED socket kit. If I open this up in the wiki, all right, you see it's going to open up, and the wiki pretty much is adjustable. Okay, so the wiki pretty much gives you everything, right? So it tells you, hey, it's 3.3 to 5 volt adjustable groove compatible interface, and it will tell you the guitar port 2, you can connect it to it, all right, and then it will give you some very simple sample code. All right, so remember that we are this here, so it'll give you where is it? It will give you general connectivity here. Okay, it will give you a general connectivity to connecting with stuff. But remember that we're using XIAO, it has to be what? D. You have to prefix the pin with D. Is that okay? So in this case, they put it on D10. So I'm going to go ahead, connect this to our XIAO digital pin 10. All right, and then we'll come and play around with it. So let's go to the bench. And I'll just look at it and see where 10 is and connect it to it, because this is what I want to connect to it. All right, so if so, yep, ground volt. So let's see. And in terms of the connection, so let's go back and look at this. I want to be sure. Okay, so there are 4 pins. So mostly the pin out allow you to know. Sorry, I'm on this screen. I'm trying to look for. Okay, so there we go. Yeah, so yep. Okay, ground not connected. Signal. So signal is the yellow one. Okay, cool. So because signal is a yellow one, let's see. So this is 10. So ground volt. Where are we? Okay. So ground volt 10. Okay, 9. That's fine. Okay. Oh man. Okay, let's see. When these pins, go through. Okay, let's bring it here. Okay. Where is that? Because this is so I don't know if you can see it, but let me see if I can adjust it a bit. Okay. Okay. So now I'm trying to figure out how I'm gonna. Okay, if I tilt it this way, do you see it? I think yes. If it's this way, yeah, you can see it. Um, so it's not directly. You know what? Let me elevate the whole of this here. Okay, cool. So you can see that it's on. Awesome. So I had to change. I had to change this. I had to change it to pin 9. Okay. So let's go ahead and now let's bring in our, well, we're going to close serial monitor for now. And I mean, just so we are working in the same space. So what I'm going to do now is we don't need to do anything in that sort. So we'll just go ahead and define. Let's make this a little bigger so you can see what we're doing. Okay, so we'll just go ahead and I'll define. So this here, I'll just call it LED. So LED pin here is now D9. Okay, so that sets up. We know where the LED is. Okay, we're putting it on D9, and then let's go ahead in the setup. Whilst I mean the LED is easier, to set up. So I can come here and say let's do pin mode, and then we're doing LED pin. We're setting that as an output. All right. So this pretty much says that, hey, our LED pin, which we're defining here as pin 9, is an output. Okay. So let's just make sure this is fine. Okay. And pretty much that's it. Okay. So what I want to do is that, let's say for delay, let's delay for a while. And what I'll do is we'll do digital right. Okay. And then LED pin, we are pulling it high. All right. Okay. So we're pulling it high. We wait. I mean, yeah. I mean, we can do this. We wait for this. And then so this is already high. So I think what I'll do is let me pull it low. Okay. And then after a while, let's say 5. We'll go ahead and pull this high. Okay. So yeah, this is just for it. So we'll turn it off, wait for like 5 seconds, and then we'll put it off. Okay, and then the loop, the loop continues. Okay, so let's save this. Let's test to be sure that our code doesn't have any errors. Okay. And that's running. So the whole idea would be that when this runs, I mean our Bluetooth server is set up, but in the loop, we're turning the LED on. This is just an initial test just to make sure that it's working. Okay, that we can get the LED to work. So let's just wait for that to build. Or why I keep saying I keep saying build to how do you call it, to compile. Okay. All right. And I'm deliberately building into this because we want to leverage the Bluetooth thing. And eventually what might happen will be just to extract the characteristics setting, so that we can even use that to send values, in setting intervals to the device. Okay. I mean, and again, disclaimer, this, I won't say that this is best practice or proper practice. Okay. It's just to show you how to do it. But if you're going to do something deployed in on a device for production use, you need to consider sleep times, wake, you need to make sure you're doing it right, so that you don't exhaust the battery, on the XIAO. Because if you keep doing this, and I mean, you're going to kill it, right? So, and that's something we can talk about at another time specifically. It says what? What? Yep. We missed this, we missed that. Thank you. Let's try this again. Yeah, it told us we made the semicolon before we moved to the delay. So you see? Yeah, and that's why I'm hoping that by now the Arduino IDE 2.0 is out, which allows you to pretty much cut some of these, syntax errors before, even hit compile. All right. Yeah, and yeah, if you have any questions, this will be the time to drop it. Drop the questions if you have any, and I'll try to answer that for you. Okay. Let me bring this up some more so that we can squish this here. Yeah. Yeah, if you're joining us from any of the either LinkedIn or in this case YouTube, just give me a thumbs up. Get me, just hit, just say hi or something, and I would okay, let's see. Yeah, it's taking a while to compile. I don't know if it's because I have a lot of things running, but okay. Yeah, I should get some, some music playing in the background when I'm waiting for this, instead of me doing this awkward talk. Okay, I think it's going to compile. Where it's got to now, it can't go wrong. If it goes wrong, oh man, I will be smacking my head right now. Yep. Looks like it's working. There you go. It's all okay. So now let's upload the sketch onto the board. So we'll see. So again, I was giving a scenario that this could be used where you have an app accompanying, IoT solution. Okay, you have, let's say you have a smart bin, or you have some, standalone system where you want to, like, let's use a smart bin for example. I want to check the status of the bin, whether it's like the volume, whether it's full. Even though you get notification, you can have, you can use a XIAO, and then you can just call it, and then it will report the states to you, via Bluetooth. So the bin doesn't always have to be online, something like that. So as you can see, it's compiling 100. Reset. That is done. Let's go to the bench, and hopefully, do you see that? Look at this. So the light comes on, is off now, it's on. It's going to be on for like some 2 seconds, go back, wait for like 5 seconds, and then come back on. So success, first step checked. All right. And that's how you need to approach when you're building stuff. You need to start incrementally, break the whole thing into smaller chunks. All right. Do the first one, check it off, move the second one. So now that we know we've gotten our code, that will allow us to turn it on and off. Okay, now what we can do is, now we know we have set it up. Now the next thing would be, at this point, if you look at the callback, let's go to the callback. If you look at the callback that is being collected, so now this is what's happening. So there's a new value, and sorry, oh man. So depending on the total value, okay, depending on the total value that so whatever you send, okay, so it prints the value inline. Is that okay? It prints the whole value inline. Now, hold on. I don't want us to complicate this thing. Now, you might say that, oh, because it's coming character by character, I want to read all the characters. Okay, I want to read all the characters, store it in some variable, and then act on that variable. Okay, but in this case, because it's coming in character by character, what we're going to do is that we would just, in this case, we know it's going to be 1. Okay, we know that the length is going to be is just going to be 1 character. So now we're going to use an O for on, and then an F for off. Is that okay? That's just what we're going to do. Okay, that is just what we're going to do. Very simple. And then, I mean, this could be, and later on, your homework could be, you can store the whole thing, use a button, whatever that is. Okay. So in that case, since we know that the length is greater than 0, we have something. I'm going to, will not print. I mean, yeah, let's change this. Let's change this one now to command received. Okay, and then the value will be here. Okay, so now it prints and then it puts the value on there, but the value is what, okay, the value is what we want, right? So this is the value. All right, this is the value. So the value here, this pretty much gets the value which is already stored here. So after you do the whole of this, right, so we know that the value is here. So let's just do this. After this is done, how about we just do print let's print this. So it's going to be the value. This is going to print the entire value. Let's put this on a new line. Okay, and let's just print the value. Okay, so I'm just going to straight deploy this. Okay, so again, like I said, baby steps. We are just trying to assess or ascertain, checking it off, breaking this big thing. What's the challenge? The challenge is that we want to either turn the LED on or off based on the command we get from how do you call it? Based on the command we get from the Bluetooth app. If we get, let's say, an on or a 0, okay, what's this saying? It says that why is it saying multiple libraries were found? Serial.print. What is happening? Okay, let's go. Oh, this can be, hold on. Yes, so let's see this. If the value of length is that, yeah, there's a string, so we're getting the value, and yeah, we're printing this. So okay, let's see. Serial.print. No matching function call for, really? On that string? That is interesting. hold on, let's see. Hold on. So this is where I consult the gauze. This can be right. Hold on, let me take this out. Or better still, this is going to print in one after the other onto it. Okay, unless it's a yeah. Okay. Okay, you know what? Let's see this. So the length, but what if, okay, hold on. I'm not sure what just happened here, but what if we just, okay, what if I just did this? No. Yeah, okay, let me see if it would allow me to print this. There you go. And I'm going to try this again. That seems so strange. Yeah. So yeah, I thought as much. Yeah, it won't. It's a C. Yeah. It won't allow me to do that. Oh, sorry, I missed this. Yeah, it won't allow me to do that. I'd have to change. Yeah, I'd have to either read it. I have to either read it one after the other, just like they're doing in here, and pass that in. Let's see. Let me try this. Else, I'll just go ahead and just use it as a yeah. It won't let me do that. Okay, because of standard string. Okay, no problem. So let's do this. If we did this, and let's think through this a bit. If we let's see. Let's see. Okay, so let's try this. I'm going to try something. A consultant the Oracle to solve some problem. Yes. We'll have to switch. We'll have to cast it. Yeah. Let's see if this would do the magic for me. So let's see. Okay. Where is that? Okay. So, let's see. because the things are not coming. Well, it's probably coming in. Okay, how about, because I don't know. Okay, you know what? Let me try this right here. Let's try this for now. No, but I would have to cast it anyway. So I'll cast it, but I'm just trying to see something. Bum, 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 ba, bum, 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 ba, bum, 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 ba, bum, 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 bum. So let's try this and see. There is okay. There you go. So that's running out. But funny enough, the okay. So if I were to convert it to string, okay, hold on. Let's check this. Let's check this real quick. Let's bring reflector. Don't worry, we are almost at the ending part of this. I'm going to connect to this again. Oh, hold on. Yeah, there you go. So 3944. Yeah, I'm just so there you go. Let's bring it up. IoT Tuesday ESP. And while this is happening, let me go ahead and open the serial monitor and keep it here. Where is our, there you go. Let's push our app here. Connect with it. Let me change it to string. And we can see it's connected. Let me write a new value. And then I'm just going to write on. Done. Do you see that? So you see what's happening? Yeah. So it's reading it value by value. But now I'll try to cast the whole thing to string and output that, and then let's see what happens. So let's go here. And this time around, so let's try printing this. Actually, you know what? After it's done, I'll print a new line. And then let's do the value dot to string. And let me try this. Okay. Yep. Yeah, and this is the next step of what we're trying to do. So the only thing I'm trying to do now is to say that, hey, I want to cast the value to a string so I can have the entire value. Okay. Else I could just go off with the first value in there. Right? So I can allow it to do everything it's doing. All right. And this is just to output it, but if we have this to work, then it means that we don't need the line where we're cycling through it. It's redundant. The key thing here is to say, hey, yeah, okay. So let me see this to this dot c str. Please be nice with me. Please be nice with me. Please be nice with me. Yeah. Yep. These are some of the things that you get to, struggle with. Yeah, if you can do car name. Okay, so let's see this. Let's see this. If this is interesting. This is interesting. Okay, you know what? Let's do it quite simple. Let's not stress ourselves. Now we know that we can get the first character, which is an O and O. Okay, so let's go with that. So what I'm going to do is let me copy this. So this is when it receives. You know what? We don't need this too for now. So let's go ahead in the callback. Since it's the callback that is going to have all these things. Okay. Okay, so in the callback, and then this time around, we don't need this in the loop, but I'll take it off. So now in the callback, all we want to know is first off if there is a command. Okay, so I will just well, that's fine. We can print it. Okay, we can still print it. We can print it, and then after we print it, now we can now check to say that okay, if the value at the initial index, this is equal to an O. All right, and this is just us doing, all right, then I can go ahead and do the digital.write. Let's copy this. Okay, we can do the digital.write, turn it on. Okay, else any other command, all right, or I mean we just leave it this way, quite simple. And then let's copy the same thing here. And then now ideally what I can do is that I could extract so sorry. So what I was saying is that ideally you see this two, I could extract it into a function on its own. And then in here just call toggle light. Okay. And then when I call the toggle light, I'll pass in this value. All right. But like I said, we're just doing simple things just to make you understand. So in this case, now we don't need this. We don't need this here. And so the only thing I'll do is that because I know that normally the LED is on, I'll just go into the setup. And after that is set up, I'll just turn it off. Okay, by default. So what are we doing here? All we are saying is that, look, if there is a value, if there's a callback and there's a value, all right, after you've displayed the value, check if the first letter of the value is O. If it's an O, turn the light on. Okay, if it's an F, turn the LED off. Quite simple. So let's push this. We won't get into the the whole intricacies of passing the whole thing. This is just to make it very easy. Ideally, we can convert the entire thing into a string and then do whatever we want to do with it. But I'm just showing you quite simple. So once this picks up, I would can I bring the bench? No. We would have to do a 4 split. No, I think we can still do it. We can do a 4-way split on this. Okay, so let me go ahead and okay, it's, as you can see, it's connecting. Actually, it's deploying, sorry. It's resetting. Okay, and there you have it. So now are we still connected? No, we are not. So let's connect to our phone again. So 7865. Okay, so as you can see, let's connect to it. It's connecting, connected. Let me change this to string. So as you can see, we are connected. Okay. And let's bring the serial monitor and let's bring our phone. Okay. And let's clear this. So at the moment, if you go to the, you can see that the LED is not on. All right. It's not on here. So if I go ahead, all right, if I go ahead now, oh, sorry, my phone just, and then write a new value, okay, of O, which is supposed to be on, right? Done. Now check what happened. Let me go to the bench again. See, the LED is on. Do you see that? So all I did was to send the command O, which, so actually let me see if I can do a 4-way split here so you see what's happening. So you can see that the LED is on here. It might not be, let's see if I can. Yeah, maybe let me just do it this way so you can see. Oh, come on, don't go off. Okay, so let's see. All right, so I'm going to do this so you can see it's on. So I'm going to go to my phone. My phone is on the top, so I'm going to write another value, and this time I'm going to write an F, which is for off. So send this. Do you see that? And the LED is off. I'm going to send another value, which is on. Send, and look, the LED is on. All right. So that is how simple it is to create. So assuming this is your own app, now here you're entering 0, O, and F, all right, for on and off. But ideally, if you created your own application, it will probably be a button, and then on a click of a button, you would send such commands to your your XIAO, okay, through Bluetooth, and then you just have to write some callbacks or event handlers. Okay, we call them event handlers. You write an event handler that says, hey, when I click this button on my app, send a 0 or on or off through Bluetooth to my XIAO, and your XIAO here in the event listener will say, hey, anytime you get an on or off from the Bluetooth, serial or however you're communicating, do this, right? So that is how simple it is to communicate using Bluetooth via an app through your XIAO to control LED. Now, this could be anything. Today, we're using LED simple on and off. It could be a relay to turn the relay on, to turn on a light, a fan, a pump, or something. All right. Now, what I'm going to leave to you is your homework. Go play around with this. Try connecting different hardware, and yeah, have fun. And like I always say, if this is something you want to do every week with me on Tuesdays, then please subscribe to the channel, hit the notification button, and when I go live, you can get notified. And if you have any concerns or any ideas on projects and stuff like that, hey, feel free to send me a tweet, a message, a like, or any of my social media channels you see down there. As always, let's make the world a better place. Go out there. The week is just starting, but let's make it a better week. Be safe, be kind, and I'll catch you next time. With that, I still remain Samuel Adranyi. I am out.